Dear 11th class students, today we are discussing the chapter continuity. Geometrically, the graph of a continuous function will not have any jumps or breaks. Geometrically, we mean by a continuous function. A function is continuous function if its graph has no jumps or breaks. Did you understand? See, suppose see this the graph. So see this graph. So this is continuous function graph. Continuous function graph would be like this. There won't be any jump or break. So it is the geometrical meaning. Now, what is the definition of continuous function? So, definition of continuous function. A function y is equal f of x is continuous function at x is equal to a if f of x limit x tends to a equal to f of a. This is the definition of continuous function. A function y is equal f of x is said to be continuous function if f of x limit x tends to a is equal f of a. If that limit value and functional value at a both are same, both are equal, then we can say that the function is continuous at x is equal to a. Now it is most important for a student to learn about forms of discontinuity. Under what circumstances the function will become discontinuous, that we are going to discuss. So, forms of discontinuity. Number one, suppose say f of x limit x tends to a does not exist, say for a moment. When this case arises, if a left hand limit is different from right hand limit, if both the left hand limit, right hand limit are different, we say that limit does not exist. If the limit does not exist, then you can say that the function is discontinuous at x is equal to a. This is one form of discontinuity. What is the second form of discontinuity? The second form of discontinuity is the limit existed, but that limit value is different from the value of the function at a. Did you understand? Limit existed, but the value of the limit is different from the value of the function at that point. This is the second form of discontinuity. Even in this case also, we say that the function is discontinuous at x is equal to a. So, did you understand? Now, let us take one problem. See, f of x is given by half into x square minus 4 if 0 is less than x less than 2, and it is 0 if x is equal to, and it is 2 minus 8 into x power minus 3 if x is greater than 2. We have to check the continuity at x is equal to 2. Verify the continuity at x is equal to 2. Verify the continuity at x is equal to 2. This is the question. Okay. So first and foremost, what you have to do here? You have to find limit f of x as x tends to 2. So first I am going to find out the left hand limit at x is equal to 2. I am finding out left hand limit at x is equal to. It's equal to f of x as limit x tends to left hand limit now 2 minus. 2 minus means it is less than 2. 2 minus means something less than 2. Less than 2 is here. So if x is less than 2, okay, he gave the definition of f of x is equal half into x square minus 4. So as following the definition, then this f of x can be replaced with half into x square minus 4. Half being constant, you can write it outside to x square minus 4. Did you understand why only I chose this? Because this definition is applicable when x varies between 0 and 2. So here x tends to 2 minus means x is less than 2. So this we have to take. Now this is equal to half into, now we have to convert in terms of h. H tends to 0, h greater than 0, 2 minus h whole square minus 4. Did you understand? So now this is equal to half into limit h tends to 0, h greater than 0, if you expand this you get 4 plus h square minus 4h. If you expand this in a minus b whole square form, you get 4 plus h square minus 4h minus 4 is equal to half into limit h tends to 0, h greater than 0. Now this plus 4 minus 4 get cancelled. So h square minus 4h equal to half into, so if you put 0 you get 0, something multiplied by 0 you get 0. So please do remember LHS you got 0. LHL left hand limit at x is equal to 2 you got 0. Now let us find out RHL at x is equal to 2. So RHL means 2 plus. 2 plus means something more than 2. Something more than 2 means x in this case. So here you have to take 2 minus 8 into x power minus 3 means 8 by x cube. When x is greater than 2, f of x is defined like this. So limit x tends to 2 plus. Did you understand? So this is equal to 2 minus 8 by 2 plus h whole cube. Now limit h tends to 0, h is greater than 0. So now further if you simplify, here if you put 0 then you 2 plus 0 2 cube is 8. So 2 minus 8 by 8 is equal to 2 minus 1. This is 1. So RHL you got 1, LHL you got 0. So LHL is not equal to RHL. Left hand limit is different from right hand limit. So what you can conclude? Therefore f of x limit x tends to 2 does not exist. Therefore f of x is discontinuous at x is equal to 2 or not continuous. You can say discontinuous or not continuous at x is equal to 2. Did you understand? Dear students, our next question is, if f of x is equal k square x minus k, if x is greater than or equal to 1, and it is equal to 2 if x is less than 1, and it is a continuous function on R, on the entire real line it is continuous function. Find the value of k. As it is continuous on entire real line, you can say that it is continuous even at 1. So by given f is continuous on R, therefore f is continuous at even 1. That means limit f of x tends to 1 would be equal to f of 1. Right? Now what is f of x when x is greater than or equal to 1? K square x minus k, if x greater than 1 or equal to 1. So if you put 1, then what do you get? If you put x is equal 1, then what do you get? F of x is equal k square into 1 minus k. So this is equal to, you leave like this, k square minus, so this is f of 1. K square minus k. Please do remember, you got f of 1 is k square minus k. Here I am writing, we got f of 1 is k square minus k. Now I am cleaning this. Now let us find out f of x limit x tends to 1. So I am going to find f of x limit x tends to 1. So for that you have to first find out f of x limit x tends to 1 minus or 1 plus, makes no difference, because limit exists, because given that it is continuous function, so limit exists. So both LHL or RHL would be equal to the limit value only. So you calculate LHL or RHL, makes no difference. So I am calculating LHL. So x is less than 1 means f of x is 2. That's it. Constant limit x tends to 1 minus. Constant has got nothing to do with the limit, so it is 2. Now given that the function is continuous at 1, as f is continuous at 1, okay, this limit will be equal to f of 1. So this value got k square minus k, that f of 1 value. You got k square, and the limit, this limit value got 2. So k square minus k minus 2 is equal to 0. If you split the middle term, then you get k square minus 2k plus k minus 2 is equal to 0. So k, if you take common, k minus 2. If you take 1 common, k minus 2 equal to 0. So k minus 2 into k plus 1 is equal to 0. Plus k equal to 2 or k is equal to minus 1. So the required values of k are 2 or minus 1. I think you understood. The students, our next problem is show that the function f of x is defined as cos ax minus cos bx by x square when x is not equal to 0, half into b square minus a square x is equal to 0, where a and b are real constant, is continuous at x is equal to 0. So we need to prove that it is continuous at x is equal to 0. So in order to prove it is a continuous function at x is equal to 0, you have to prove that f of x limit x tends to 0 is equal f of 0. So now I am starting my solution. So as planned, first I am finding out f of x limit x tends to 0. X tends to 0 means x is approaching to 0 from left side or from right side, but x is not 0. So x is not 0 case is over here. So x is not 0, f of x is defined as cos ax minus cos bx by x square. So limit x tends to 0. So here you have to apply the trigonometry formula cos c minus cos d. I think you all are aware transformations. Minus 2 sin c plus d by 2 sin c minus d by 2. Transformation formula for cos c minus cos d. So here I wrote that formula clearly. So here that minus 2, okay, it is constant, you can write outside the limit, to sin c plus d by 2, ax plus bx by 2, that means x into a plus b by 2, c plus d by 2, sin c minus d by 2, sin x into a minus b by 2, okay, by x square as limit x tends to 0. Did you understand? So now what I am doing is minus 2 into, I am writing in a convenient manner, sin x into a plus b by 2 divided by x, limit x tends to 0. Here sin x into a minus b by 2 by x, limit x tends to 0. So x square I used here as x into x makes no difference. So this is equal to minus 2 into, from standard forms this results as a plus b by 2 and that results as a minus b by 2. Then this 2 and 2 get cancelled, then you get minus half into a square minus b square, which is equal to half into b square minus a square, which is nothing but f of 0. So limit f of x extends to 0, you got f of 0. Then by definition of function, by definition of continuous function at a point, you can conclude that this function is continuous at x is equal to 0, and it's proved.